Hi, welcome to section 2.7. This is going to be transformation of graphs. So we're going to move them around, up, down, left, and right. We're going to stretch them, and then we will also flip them upside down. And I guess horizontally would be an option too. But anyway, so the first two things we want to look at are vertical and horizontal shifts. So I've laid out the notes here, that the real basic notes here for you. And then I have an example, and we're going to talk our way through this. So a vertical shift takes some function that you already know and either adds or subtracts a number outside of the function. And so if you add a number, it's going to go up C units, and if you subtract a number, it will go down C units. And that one is usually a pretty easy shift for people to understand, so hopefully that one works well for you. Now the weirder one is horizontal shifts. Horizontal shifts, the addition or subtraction of this number is on the inside with the x. So you're going to see a set of parentheses, there'll be an x in there, and then plus or minus something. But the weird thing about horizontal shifts is that they end up working backwards. So if you have a minus sign on the inside, you're actually going to shift right. If you have a plus sign on the inside, you're going to shift left. Basically, it's what makes 0. So remember with circles, we did that when we was in the parentheses there. We said, hey, that center was going to be what makes 0. It's the same kind of idea here. So here's my example. I have y is equal to x minus 2 squared minus 3. And so I don't need a super awesome graph here. I just want a real quick sketch. But the important thing is, and this is going to be really important going forward, these shifts, they are always the first thing that I do on any of these transformations because I can get them done and out of the way so I don't even have to worry about them when we get other things involved. But here's what we have. I have a minus 3 at the end, so the minus 3 tells me it's going to go down 3. So you'll notice I have a dotted line down here at y equals negative 3, and I forgot to move my chair. Anyway, there we go. I have a dotted line down here, y equals negative 3. That is what I would call my fake x-axis. And then I have a minus 2 on the inside, which I remember is kind of backwards. It's going to move it to the right 2 units. And so I have a dotted line over at x equals 2. What that does for me is it recenters my graph. I know that the graph of this will be exactly the same as the graph of y equals x squared if I just put it down here. So if I pretend that the meaning of those two dotted lines, that intersection, is my fake origin, if I use those as fake axes, the graph is exactly the same, it's just down there. And so that's really the first big takeaway we want to have here, because we're going to do all sorts of other stuff. But if you keep coming back and making those fake axes and start your graph down here, or wherever those dotted lines might be, if you do that, it's going to make all the other things so much easier when we get to them. So there you go. There's our first set of transformations. We can shift them up, down, left, and right. And now we'll move on. All right, so here we go. Now we have vertical stretches and flips and horizontal stretches and flips. And actually, this will be everything. If you can master the moving things around and then stretching, you'll be all set. So I have notes here for the stretches and flips. I have one example, and then maybe we'll do a couple more examples to finish this off. All right, so for a vertical stretch, you have something multiplied by your function. Okay, remember last time we used an x squared. Here I actually have an example with a 3 times an absolute value. And so all this is going to do is it takes every y value that you have and it multiplies it by whatever c is. It will flip your graph if c is negative, which makes sense because guess what? If you take your y values and you multiply by a negative, you flip things over. And so that works out really, really well. Horizontal stretches are going to be a little bit different. Everything horizontal is just a little bit weirder. So now we have the multiplying on the inside. Unfortunately, remember when we did left and right shifts, it was kind of backwards. If you had a plus sign, it went left. If you had a minus sign, it went right. Well, now instead of multiplying our x values by c, turns out for the graph, we actually want to divide our x values by c. So if you had a 2 there, you would take all your x values and cut them in half. You would divide by 2. And it will also flip if c is negative. So I have this example, y is equal to 3 times the absolute value of x. Now, here on the left, you can see I have your basic absolute value graph, which remember, it's going to come to a point at 0, 0. And of course, if you plug in 1, you get 1. If you plug in -1, you also get 1 because absolute value makes everything positive. So we have this nice V shape. Well, with a 3 in front, what it's going to do, notice, I took these two ordered pairs that I had. I had 1, 1, and -1, 1. Well, I still have 1 for x, but now I have 3 for y. I just multiplied that y value by 3. I still have a -1 for x, but again, I multiplied by 3. And so you can see that my graph gets a lot steeper because I multiplied all those y values, and so it's all just kind of getting stretched vertically. And so we'll look at maybe a couple more examples, and then we'll be all set. All right, so here we have a more complicated example that involves some stretching, some shifting, and a flip. So we have lots of things going on here, and really this is a pretty good problem. If you can find your way through this, you'll be okay. All right, so here's what we have. We have y is equal to -2 times the square root of x plus 1 plus 4. That's a lot of stuff. So the first thing to notice is that my basic function here is just y is equal to the square root of x. All those other numbers are just there. They're going to do things to that graph, but my basic function is the square root of x. So before I do anything else, I'm going to deal with these two shifts. I know that with a plus 1 on the inside, that's going to shift my graph left 1 unit. And with that plus 4 on the end, it will go up 4 units. So I come over here, and you'll see I have my dotted lines that I shifted left 1 and up 4. And that gives me what I would call a new origin here, way up here at -1, positive 4. And so here's the thing. Now I'm just going to make my graph, and I'm going to pretend that those are my axes. If I do that, I don't have to worry about the 1 and the 4 anymore. I am done with those. I just need to make the graph on the dotted lines instead of the regular axes. And so I'm going to point this out and see we'll see how to do it, but it really works well. So here's what we have for the rest of it. We know our basic function is the square root of x. So you'll see I have 3 columns here of x. I have the square root of x, which is a normal y. Remember, for a stretch and a flip, with this -2 outside, that's going to multiply my y values, and that's why I have this third column. I know if I plug in 0 for x, that the square root of x is 0. If I plug in 1, the square root of x is 1. And I went to 4 for my next one because, well, let's face it, 4 has a nice square root, 2 and 3 do not. So square root of 4 is 2. Now those would be the y values if I didn't have this -2. So with that -2, all I'm going to do is I'm going to multiply all these y values by -2. So 0 times -2 is still 0. 1 times -2 is -2. 2 times -2 is -4. So my ordered pairs now are these x values that I plugged in and these -2 times y's that I have over on the other side. So on my graph, you can see I have 0, 0. There's my dot right in the middle of my dotted lines. I have 1, -2. So I went over 1 and down 2 on the dotted lines, right? Over 1 and down 2. And then 4, -4. So I went over 4, down 4, and that gets me my points. And you can see this basic shape of the square root graph. It's flipped upside down, it's stretched, but it is still that same basic shape. And that's really how we're going to do this, and it works very, very, very well. All right, so I have one more example that I want to do for you, and let's get that on the board. Okay, so here's my last example. I have a graph here for y equals f of x. So notice this is not one of our basic graphs. This is just something I made up. But hopefully you can see I have 5 points on this graph. I have 0, 1, 1, 1, 2, 0, -1, 0, and -2, -1. All right, so I have this graph, and this is what I want to do with it. I want to graph this thing. Y equals 2 times f of x minus 1 minus 3. So we go through this the same basic way. The first thing I notice is that I have 2 shifts, right? I'm going to go right 1 and down 3. So I immediately put my dotted lines in to recenter the origin down here at 1, -3. Okay, that's where I'm going to start. When I do that, that means that I'm done with the 1 and the 3. Those are taken care of. I don't have to worry about them anymore. All I have to do now is multiply my y's by 2. That's what I have written here. 2 times the y's. So what did I do? I said, okay, for instance, this point right there is the ordered pair 0, 1. Well, on the new graph, we're going to double all of the y's, right? That's what that 2 is going to do. So instead of having 0, 1, I'm going to have 0, 1 times 2 would be 2. So I come over to my graph, 0, 2. And I just do that for all of these points. I just multiply all the y values, and you can see the graph that I get. The x values stay the same. I still have a point at 0, at 1, and at 2, if you pretend we're working with those, well, no pretending, if you are working on those fake axes. By the way, that's my term, fake axes. I've never heard anybody else use it, so don't tell your next math teacher I call them fake axes. All right, so anyway, that's where this graph comes from. It's a pretty neat little problem, and I like it. So good luck.